Have you ever been fascinated by rockets, how they work, and the programs used to calculate their flight path and exactly how they fly? I have been. So I challenged myself to learn Python in 5 days and build a program, and here we are. Hello, my name is Aryan Chatterjee and I have successfully built my aerospace calculator. I'll show you guys exactly how to use it, what it does and what it utilizes and what it gives as an output. Let's do this. So this is the aerospace calculator and this is the Indian Space Research Organization's data which I have used for this calculator. So first, when you run this calculator, it gives you a description of the program, what it uses as an input and what it gives you as an output. So it uses the input of the vehicle name which you want, vehicle type, vehicle name, and the target delta V boost. Now the target delta V boost is basically the speed budget for the aircraft, which gives you the maximum speed which can be given to the aircraft from where you are to where your destination is. And it gives you the total fuel required, maximum tank capacity, leftover propellant reserve, and mission status. Now it gives the 6 satellite vehicle categories which the Indian Space Research Organization uses. For example, the PSLV, Polar Satellite Launch Vehicle. This was used for Martian interplanetary trajectories and lunar trajectories for the Chandrayaan 1. Right? For one, I'll select the LVM3 which was used for Chandrayaan 3. So select 5. Now the LVM3 in the database, it has only one option, the Chandrayaan 3. So I'll select 1 and I'll give 2800. See, simulation profile, vehicle family, calculated fuel, maximum tank capacity, and mission successful. It basically gives you all the details and shows you whether the mission is successful or not. Now let's use this again, but for another vehicle type, so you can see exactly what of the database it uses. So we're going to run this mission again. We're going to run in debug, run it as a Python file. Now we're going to choose PSLV. It shows all of the 58 vehicles which were used by the Indian Space Research Organization of the PSLV type. We're going to go to 26, the Mars Orbiter. Now I'll give it an unrealistic velocity budget like 4000, let's assume. Mission failed because 2500, this is the maximum capacity, and it ran out of fuel mid-maneuver because the vehicle tanks are too small for the fuel which is needed for the maneuver. So this is what exactly this program does. It calculates using the Tsiolkovsky equation the probability and the success of an aerospace mission being successful based on the target V delta boost which you have provided it. So yeah, that's basically how the project works. And follow for more. Over the course of the next few weeks, I'll be making more projects, and specifically for this project I have more plans as this is my first project ever. And over the course of the next few weeks, I'll also be explaining the Tsiolkovsky engineering equation as well as other engineering equations and the technical aspect, you can say, of what was needed and what all knowledge was required for the making of this project. But yeah, thank you. It was a pleasure to share my projects with you, and have a great day ahead.